Okay, welcome back to the new part of my tutorial series of how to create your first GN4 project. Now, in the last part I have explained how you can create the outer shell of your project, including the run manager and all this, which you can see here on the right side. And now in this step we go one step further and put some life into our detector, which means we create the detector geometry. And for that purpose we have to inherit from a specific class which is implemented in GN4. So we have to write basically our own class. Therefore I recommend that you also put all this definition in a separate file in order not to occupy this main file. And therefore we will create in the, not in the build folder, but one folder above, a file, let's call it construction.cc for the source and construction.hh for the header file. Now, so there's no nothing really complicated in that. We only use the possibility of C++ to create some classes and put them in different files. So we will start with this with the header file, and we use this standard trick as we are normally using in header files to make sure that it will not be included several times. If not defined, construction underscore hh, then define the same, and if. Yeah, so now we put everything which is related to our header file in between that. So as I said, we write our own class, so we just call it my detector construction. And again, you can give any name, whatever you like, but I think this sounds reasonable. And this, as I said, has to be inherited from the so-called G4 user detector construction class, which is implemented in GN4. And here not so many things have to be included. So basically the most important thing is of course the constructor. So we just copy paste it from here, and we also need destructor, which we can also copy. And now the main part of this class is basically the function G4 v physical volume, which is basically the return value of this function. And the name of this function is construct, which is the main function that constructs the whole detector geometry. So the whole description of the detector has to be put into that function. And of course it should be a virtual function because it is defined in that function, in that class implemented in GN4. And as you can see, we used a few things. Okay, maybe this we can do later. So now we will use the information from that file and include this in our construction.cc. Yeah, and then we come there. And also this is not so much complicated what we will do now. Of course, the first thing which we do is the dealing with the constructor, which is simple. And the same thing we can also do with the destructor again. Also, this is nothing really complicated. And now we come to that function here, which I have explained before. Correct. So we have to basically copy and paste that. And write now all information that are important in this function. Of course, we also have to use the class name here. Okay, so before we define our geometry, we have to define a material. Yeah? Without a material, a detector cannot work. So you can of course define your own material as you like to do it, but I recommend that when there are materials in GN4 available which you can use, then don't reinvent the wheel, but just use already what is there. And for that we can use some class in GN4 which is called the G4 NIST Manager. Correct. And just call it NIST equal to G4 and ist manager, and it is, I think, a singletonian, so you can just get the instance from that. And yeah, then you basically use now this manager in order to get some parameters which are predefined for different materials. So let's suppose we want air. So we define a new material which is called G4. For that we use the class G4 material, and we call that maybe world mat for world material. And then we use this NIST manager and write find or build material. This is the name of the function, G4 air. And then this manager search for the material, predefined material, which is called G4 air, and then yeah, and then defines the material world mat according to that. Okay, this is in principle everything. Now we have a material for our world volume, which is called world mat, and which contains air. And it's very important that we have a world volume. So all our physics processes must happen in a boundary, which is called world volume. And this is also what has to be returned at the end. So it's not possible to create any detector construction or geometry without having a world volume. And in our case, we can just make it simple, a box. So the class which we use for that is called G4 box. And this volume which we create now, this world volume, or every volume which you create in GN4 has to contain 3 parts. One is the solid, which basically defines the size, for example. Then we need a logical volume, which includes the material. And finally, we need the physical volume, which places then the volume in our GN4 application, together with rotation, translation, and yeah, tells, for example, the copy number to GN4 and so on, and creates really a volume which can interact with particles. So we have to always, when we create a new detector, we always have to create 3 different volumes. So now we create first the solid one. And for that we use this class G4 box in order to create a box. New G4 box. And the parameters that are taken by the constructor are first the name, and in this case we call it just solid world. This is the name of our world volume. And then we can write and then the half size in X, the half size in Y, and the half size in Z direction have to be given. So we just make it easy at the moment and create a volume which is 1 meter, has a width of 1 meter, a height of 1 meter, and a length of 1 meter. So in principle we should write here 0.5, 0.5, 0.5. As I said, this is half of the length that we are giving. But the standard unit regarding length in GN4 is, if I'm not completely wrong, millimeter. So we have to tell now GN4 that we want to use meter. And for that purpose, we have to multiply it with m. And this, of course, this m has to come somewhere. We have not defined it anywhere. So we go back to our construction.hh and we include here a file which is called, now I also have to basically look it up, G4 system of units.hh. And now we can use different units which are pre-implemented in GN4. For example, yeah, regarding the length, we can use meter. Regarding energy, we can use giga-electron volt. We can use degree in order to convert radian to degree and so on. So this is a very important header file which I can always recommend to insert. Okay, so now we created a box with the length of 1 meter, width of 1 meter, and height of 1 meter, and the name solid world. And this, of course, only tells GN4 the boundary, I mean the size of this volume. And now we have to define, or we have to insert that material that we create into this volume. And for that we create a new logical volume. And now we just call it logic world, of course. And then the same again, logical volume. And now the first parameter that we have to insert is the basically the solid volume that we defined. So in this case, solid world. The next parameter is the material, which is in this case world mud, which we defined before. And the last parameter is the name. So in this case, it would be, let's call it logic world. Now we created our logic material, logic volume. Okay, in principle also very simple. Nothing really complicated again happening here. And the last thing is the physical volume that we have to create. And in this case, we just call it phys world. And now we have to use the class G4 PV placement. Exactly. So this is this you always have to use, and when you do that, then you are completely on the safe side, because you can basically just look it up what the parameters mean. I can just tell it now, and then in future you can use the same parameters again. So the first one is the rotation. In this case, we don't want any rotation. We just want the world to place it inside as it is. So we just write a 0. Now we want also that this world is centered at the center of our coordinate system of GN4, so at the position 0, 0, 0. And what it takes here is another class in GN4 which is implemented, which is called G4 3 vector. This is very similar to the root class called T vector 3. A little bit different, but it does a similar job. And then here in this constructor we have the coordinates in X, Y, and Z direction. So we want to place it, as I said, in 0, 0, 0. Then the next one is the logic volume, which is in this case logic world. And then the name, which would be in this case phys world again. And then you can tell GN4 that this volume should be placed in another mother volume, which is in this case, of course, not true, because this is the mother volume already, so we can just write a 0. So the idea is that in GN4, when you place a volume inside another volume, then this previous volume above that must be the mother volume of that daughter volume. If you don't do that and the volumes are overlapping, it creates some very interesting effects, very undefined states. Therefore, it's always important that every volume, if it touches another volume, it must be completely incorporated by that volume. And this other volume then has to be defined as a mother volume. Otherwise, it creates a lot of trouble. Therefore, this physical volume has no further mother volume, so we can just write a 0, as I said. We don't want to implement any Boolean operations so far, so we can just write false, and for the most of the time this is just false. Then the copy number, if you insert one logical volume several times, you can define a copy number that we can use later for other purposes, but also here we don't want to do anything special with that, so we just write 0. And we only create it also one time, of course. And the last one, the last variable we set to true, and this is the question whether it should check for overlaps. So this you should always set to true, because when you have an overlap, as I said, which is very bad in GN4, then it detects this overlap and gives you a warning message. Then at least you know in the beginning, after creating the detector, that now there is a problem, you have to deal with that. Otherwise, it is really bad. So better to always set it to true. It might take a little bit time sometimes if the detector is very complicated to go all through the elements and check whether they are overlapping. But at the end, you are quite happy. This I can promise. So now we have our physical volume, which is called physWorld, and this we can return. As I said, always the mother volume, the highest mother volume we have to return. And now when we want to create further detector parts, then we have to place it inside that world volume, and then if we want to create another mother volume, we have to create a daughter volume in that, and so on. As long as they are not touching each other. Okay, now we have this, and now we can tell GN4 to use that geometry that we have just created. And for that we go back to our run manager and write here run manager set user initialization new my detector construction. Okay, and then as I said in the last video, we have to write here one time run manager initialize so we can use this geometry at the end. And yeah, this is everything. Now we also have to, of course, include our detector file construction.sh, otherwise it will not find that class. And I think here we forgot a lot of header files, which I was sparing until the end. So what we need here, what we have used, of course, the class here, G4 user detector construction.sh. What else we have used is G4 physical volume.sh. Then we have, of course, used G4 box. Then we have used the class for the placement of the physical volume, which is this one here. And we have used the NIST manager, which is that one. Yeah, and I guess it's not physical volume, it's G4V physical volume, by the way. And we have to use G4 logical volume. I think this should be everything. Now we can test it. First we have to run CMake again because we created two new files, and we have to tell CMake that they are there, so we have to run that again. And now we can basically try it, which gives an error message because it's also not G4 user construction, but there must be again another V included, G4 V user detector construction. Yeah, there is another problem regarding semicolon, which maybe I forgot. Okay, sorry, it must be here in that. Of course, yeah, I think I know it here. G4V physical volume, as I said, this has to be a V. Now slowly we can try to debug it. Okay, now it runs perfectly. Now let's run it. Yeah, it gives you again an error message, which is perfectly okay, because now before we can really have a look at it and see whether it works, basically I can try one thing. What happens? Yeah, okay, no, it has to be initialized, otherwise it will not work. So yeah, we can keep it as it is, and before we can really see what is going on, we have to implement a physics list And I think we also have to, just let me briefly check it. Yeah, we have to basically implement the physics list. Yeah, this is very important, and this will be the next step. So after finishing that, then we can basically run it, and then we should be able to see our detector geometry. And also after inserting the particle gun, which will be then in the tutorial after the next tutorial, then I will explain how to do that. And then we are very near to finalizing our program and to run it. Okay, so yeah, I hope you enjoyed that so far. If you like it, please stay tuned. If you have not done so far, please subscribe to my channel, and then hopefully see you next time.